Welcome to week 2. We're going to start with new KNEW 4 FORE. Week 2 is June 29th to July 5th. Happy 4th of July. The review topic we are going to be working on this week is exponents. Exponents is going to be broken up into 3 parts. So exponents is basically all we're going to be working on in the review part this week. And it's just going to be kind of taken from start to finish. So we will start now. So looking at exponents, the directions across the board will be to simplify these. You'll notice that when we see the directions to simplify or evaluate, there will be no no equal sign. And here we don't see an equal sign. With that, in addition to either simplify or evaluate, we do not want any negative exponents ever. We want always to end with a positive exponent when we're working with exponents. So our rules for exponents, when we are multiplying exponents, such as we are here, our base needs to be the same. So what is our base? Our base is this right here. So our base is, if we have it right here, well, I'm going to change that right now. Hang on. Okay. And the reason why I wrote it like this is because that is our base. Okay. This is our exponent. And then this whole thing would be called our power. Okay. So in order to multiply this, we would need the same base. So when we have the same base, we can actually, and we're multiplying the bases, we can actually add our exponents. The reason why we can do that is because when we have x to the third here, we have 3 x's. So we have x, x, x. And then when we have x to the ninth, we have 9 x's. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we wouldn't want to do this when our numbers are too big. And this is kind of like the longhand. We want the shortcut, but when we look at the long drawn out version of it, we see why the shortcut works. And when we look at this, we count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We would really have x to the 12th, and we see why this works. 3, 9, 3 plus 9 equals that 12, and our answer is x to the 12th. Okay, for number 2, we can do the same thing. We have 3 7 times. 1, 2, 3, 4, 5, 6, 7. We have 3 4 times. 1, 2, 3, 4, which really means we have it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So we really have 3 to the 11th time. Notice that we don't touch the base. So we don't touch that big number, right? Even when it's a number base. So here especially, we don't make that a 9, we don't make that a 6, we don't add it, we don't multiply it, we don't change the base. The base stays the same. So whether it's an x, whether it's a 3, whether it's a, whatever it is, it stays the same. And we add again, the exponent. So 7 plus 4 gives us the 11. Now down here for number 3, notice our bases are different. So right here, we look at this, we have an A and a B, so different bases. We cannot then add the exponents. So because of this, our answer for this stays exactly as our problem started, A to the third, B to the second, and we're done. Bases are different, so we cannot combine anything, and we circle our answer. Number 4, if a base doesn't have an exponent on it, it is understood to be a 1. So on this second A, we have a to the 10th A to the 10th times A. On that second A, we can actually put a little 1 as an exponent, because if there's nothing there, it's understood to be a 1. And then we can kind of longhand it and write A, 10 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times A again for that 1. And if I have 10 A's and then I have another A, I really have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So I really have A to the 11th. Notice that same rule applies, same base, and we're multiplying, we add our exponents. 10 plus that 1 equals 11. So we have A to the 11th. All right, let's move down here. Number 5, we have a number in front of our X. So we have a number 7, okay? And we have no number in front of this X. So because we have no number in front of that X, and then the 7 doesn't have an exponent, we really have a 1 here. It's understood as a 1. So 7 times 1 just gives me a 7. It's a coefficient, and when we have coefficients, we multiply them. So 7 times 1 gives us 7, and then we do the same thing we've been doing with 1 through 4 with the x's. So let's shorthand it. Let's do our trick now that we've seen what happens. If I have x to the 8th and x to the 4th, we have the same bases. We're multiplying them. So when we're multiplying them, we add the exponents. So we really have x, and the 8 and the 4 would get added together. So that really gives me 12. Now, if you want to still write them out, x, 8 of them, and then 4 more, that's fine too. You would still get 12 of them. You would see that. And our final answer is 7x to the 12th. All right, number 6. So we see here's our coefficients. We have a 3, and we have that -2. So 3 times -2, we get -6. And now we have the y to the 2nd and y to the 3rd. We're going to do the same thing we've been doing with the last few, okay? If we want to do that same thing, we have y for the y to the 2nd, and then we have y for the y to the 3rd. So we see right there we have y to the 5th, okay? Or we know we have 2 y's, 2 plus 3, which gives us 5. So our answer is -6 y to the 5th. Now, they're getting a little bit longer. okay? But they're not any more scary. We're just going to do the same thing. Here, we're going to grab all of our coefficients. I have a 5, I have a negative 1/3, I have a 9. Now, I'm going to use that trick that we did on our live last week, okay, the one that got interrupted at the end. And I'm going to use it with the negative 1/3 and the 9. Now, why I'm going to use it with those is because I know right away that those are my multiples. That 5 is kind of my odd man out. So I can kind of come down here and see that the negative 1/3, the 9, and then the 5, okay? These are the ones, they don't match up, but 9 divided by 3 gives me a 3, okay? So 3 times negative 1, or I can bring down the negative, right? So 3 times 1 gives me 3. It was negative, so negative 3. And then I still have this 5. So my answer, my coefficient answer, is negative 15. Now I have to go back up and do my letters. So I have to worry about my letters. So I have A, and I don't have an A in my last parentheses. So A times A. Well, the first A has a 1 on it, and my next A has a 1 on it. So I have one A and another A. So I have A to the second. All right, now I have to worry about my B's. I have a B and a B squared. Well, this B has a 1 on it, and this B has a 2 on it. So I have a B, and then I have a B. So really, I have B to the third. So my final answer is negative 15, A squared, B cubed, or B to the third. All right, so let's look at number 8. First, I have to worry about my coefficients. So let's pull them down and worry about them first. I have 1/3, I have 3, and I have 7. Just worrying about all just my numbers. All right, well, again, using my trick from my live, I'm loving this. Because look, there's my numbers that match up. So when my numbers match up, they knock out. So the 3's match up, they knock out, and it leaves me with just the 1. And the 1 times the 7 gives me just 7. Now, I'll try the highlighter. Maybe that'll work nicely too. All right, x's. I have x to the third. I have no x's in the second part. And then I have another x. All right, so if I'm writing all my x's out, I have x, 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 and then I have another x. So how many x's do I have? I have x to the, how did that get to my eraser? X to the 4th, because I have 1, 2, 3, 4. All right, going to y's. I have y to the 4th, y to the 2nd, and I have no y's in my third set of parentheses. So if I'm writing out my y's, I have y, 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 and then I have y, y. I'm just using a little bit of separation so you can see, the different parentheses. My dog is snoring next to me. I don't know if you can hear him. If you can, it's the most adorable thing. All right. So back to my y's. I have 1, 2, 3, 4, 5, 6. So I have y to the 6th. Trying to pick another color. That one looks good. All right. For my z's, I have z and z to the 4th. So if I have z and then z to the 4th, I have z, 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 z. So that's 1, 2, 3, 4, 5. So that's z to the 5th. And my final answer is 7, x to the 4th, y to the 6th, z to the 5th. All right, so on to the next page. Now these they look like division problems. So whereas multiplication, we ended up adding the exponents, you'll see what happens here is a little bit different. So we talked about the fraction bar acting as if we divide. It's definitely going to act as a division bar, or like a dividing, it's definitely going to act as a divider, right? So when we draw this line, we're going to have 10 tens on top, and we're going to have tens on bottom. Now, how many tens are we going to have on top? We're going to have 7 of them. I think I have 7, yep. And then we're going to have 4 tens on bottom, right? Because we're going to have 10 times 10 times 10, because really 10 to the 7th is 10 7 times. And 10 to the 4th is 10 4 times. Now, what happens is, basically, if I were to say, away from this problem, 10 divided by 10, we've talked about this. Anything divided by itself is equal to 1. So if I cancel any one of those mini division problems out, I can do that. So here, that divides to 1, that divides to 1, that divides to 1, and then that divides to 1. What I am left with is 3 tens on top, or 10 to the 3rd. And you're done. So if you look, realistically, what you did was you subtracted the exponents, right? 7 minus 4 gives you 3. So let's see if that was a fluke, or see if that would happen again. If I draw that dividing line out and I put 11 x's on top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm only putting 1 on the bottom, and I'm canceling 1 on top and 1 on the bottom. How many is that going to leave me with? And where is it going to leave me with it? It's going to leave me with 10 x's on top, right? And essentially when I do that, it would be x to the 10th over 1. This 10 to the 3rd would be over 1, right? The over 1 I can drop, just leaving me with 10 to the 3rd, or x to the, whoops. All right. So this just leaves me with this x to the 10th. Now, if I go to this next one, again, using this dividing line, I have 7 to the 6th. So I have 7 6 times. And I have on the bottom 7 6 times. Sometimes it's a little bit confusing when you have the numbers. But remember, your base, your big number, base, big number, okay? That's the easiest way to remember it, is the number that you have. The exponent tells you how many times you have that number, okay? So base, big number. Exponent tells you how many times you have that number. So I have the 7 6 times. And I have them an equal amount of times, right? So what's going to happen when I cancel? Well, 7 divided by 7, 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 7 divided by 7. Remember, this is where I don't want to think about canceling turning to, quote, nothing, right? Because when you think about it turning to nothing, then you have nothing left. But when you think about it dividing to 1, each one of those dividing to 1, then the whole problem turns to 1. So this whole thing equals 1. All right, number 12. Dividing this problem out, I have 13 x's on top. And I have 8 x's on the bottom. I'm canceling or dividing out each one that I can. And I'm counting how many I have, where they're left. And I end up with 5 x's on the top. So I have x to the 5th. All right, number 13 now. Only difference with this one is that I have a coefficient. I have a 3 on the top, and then I have x to the 5th, so I have the 3, and then I have 5 x's. On the bottom, I have 5 x's. The 3 I have to leave alone. The 5 x's I can knock out with each other, leaving me with a 3 on the top. Now, I could put a 3 over 1, which really, 3 divided by 1 just leaves me with 3. And I'm all done. Number 14, I have 12 to the 7th power. And then that's divided by 12 to the 10th power. Now, here's the first time where we see a bigger exponent on the bottom. And here's where that negative exponent that you were probably starting to wonder, that no negative exponent rule comes into play. When I draw out 7 12s, because remember, the base tells you what number you have, the exponent tells you how many of them you have. So I'm going to write out 12 7 times. So I write out 12 7 times on the top. I write out 12 10 times on the bottom. Okay, so I have 12 7 times on the top. I have 12 7 times on the bottom. When I knock these 12s out, I notice, and I definitely drew one too many, that I have 3 left. And where are they? I should have 3 left, and they should be on the bottom. Right? Because this problem is very similar to number 9, where I had 3 left with exponents of 7 and 4. But the 3 that I have left were on the top in that one. Now I have 3 left because the difference in my exponent is still 3. But the 3 that are excess are the excess is in the bottom. So this is where, when I write 12 to the third, right? Because I'm going to write 12 to the third. I have to write 12 to the third in the denominator. And what do I write in the numerator? Because there's, quote, nothing in the numerator, because every 12 in the numerator has been knocked out. I write a 1 because 1 is a placeholder. So my answer is 1 over 12 to the third. All right, let's look at number 15. I write my divider. I have 7 x's on top, and I have 9 x's on the bottom. When I knock out all my x's, I have 2 left over. And where are they left over? They're left over on the bottom. So when I write my answer, I have x squared as my answer, or x to the second. But my x squared has to be on the bottom in the denominator, and on the top has to be a 1 as a placeholder. So it's 1 over x to the second. Now, let's do number 16 without writing them all out. And I purposely picked a little bit bigger numbers to do that. If I have x to the 20th on the top and x to the 24th on the bottom, okay, what's the difference in my numbers? Where's my bigger number? How many am I going to have left, and where are they going to be? So when I knock everything out, how many am I going to have left, and where are they going to be? How many am I going to have left, and where are they going to be? So I'm going to have 4 left, and they are going to be on the bottom because I have more on the bottom. So I have 4 more on the bottom, so I'm going to have x to the 4th on the bottom. Which makes me have to have a placeholder of 1 on the top. And that's all for this one. Go ahead and practice some on the independent. Let me know if you have any questions, and I will see you all soon.